As stated in the last video, these are the 4 things we want to concentrate on whenever we are dealing with scatter plots: direction, form, strength, and outliers. So we're going to take each one of these as we go. The first thing we want to look at is direction, and there are going to be 2 real directions that we're concerned with: positive and negative. So let's start with positive and what that means. There are going to be a couple of different ways to think about this. The first one, as x increases, so does y. As x gets bigger, y also gets bigger. Another way to think of it is it moves up and to the right. So as we read the graph left to right, it's in general moving up. And here's a rough sketch of a scatter plot that is positive. In general, as x increases, so does y. As you move to the right, the graph moves further and further up. Now let's look at the negative side. The first thing is x increases, y decreases, so we have this opposite relationship going on. Another thing is it moves down and to the right, so as we read left to right, our graph moves down. And here's a rough sketch of a scatter plot that has a negative direction. As you can see, as we move left to right, the graph moves down and to the right. So let's go back and look at our 2 examples that we had earlier. This one looked at the number of absences a student had compared to their grades, and as we can see in this graph, as we move to the right, the graph is moving down. So this one is actually negative. It has a negative direction. Here's our other graph, and as we move to the right, you can see our points are getting bigger and bigger, so this one would have a positive direction. So now that we've talked about direction, let's look at the next piece of our scatter plots: form. Form is wanting to know the general shape that this graph looks like. So does the graph look in general like a line, like a quadratic function, like an exponential function, just to name a few? There are lots of different things that can be going on here. For the purposes of this class, we're going to restrict ourselves to linear, so all of our forms are always going to be linear. So that'll be an easy start for us. That form will always be the same, linear. What about the next piece? For strength, let's say we know something is positive and we know that it's linear. So the strength tells us how close the graph actually is to that line. And the way we're going to do this is known as the correlation coefficient. And we denote this by the letter R. And so before we actually go into this and show you how to find it, let's talk a little bit about it. First, R is always going to be between -1 and 1, including -1 and 1. So the sign on this, first off, if the correlation coefficient is negative, that means the direction was negative. If the correlation coefficient is positive, the direction was positive. So the sign of the correlation coefficient does tell us the direction of the scatter plot. And the closer this number is to either positive or -1 means the closer it actually is to the line. It's the closest we can actually get to drawing a line. And the closer and closer we are to 0 means that there is actually no relationship or a very, very weak relationship. So let's look at a couple of examples of this, and then we'll actually look at calculating this value. So here's an example of a graph with correlation coefficient 0 and then -0.3. So we can see that these are a weak relationship. It's not really clear that there is a good line in these graphs. Here we have one with a correlation coefficient of 0.5 and -0.7. So these would be a moderate relationship. You can kind of start to see the general shape of the line, but they're still not very close to an actual line. Here we have a correlation coefficient of 0.9 and -0.99, and you can really start to see the shape of the line in these. These are a quite strong relationship. If I were to actually draw a line down the middle of these graphs, you can see that the points are going to be very close to that line. So that would be a strong relationship. To actually calculate the correlation coefficient can be very, very tricky. There's a lot of steps to try to do it by hand, so instead we are going to use calculators and computers. So let's look at some examples of actually calculating this. Let's go back to our example of absences in student grades. We know this has a negative relationship that we talked about previously, so let's see if we can actually find the correlation coefficient. And like I said, to do this, we're going to use calculators. In particular, I'm going to use the GeoGebra graphing calculator. So here's my graphing calculator. In order to do this, I'm going to start with these 3 dots at the top right of the keyboard. And we're going to scroll down until we can select statistics. From there, we're calculating this correlation coefficient, so I'm going to select correlation coefficient. And then we just enter in our points as points. So we need to open our parentheses for our first point. The first student had 6 absences and a final grade of 82. So there's my first student, comma, the next student. 2 absences and a grade of 86, close parentheses, comma, next point. 15 absences and a grade of 43. The next student had 9 absences and a grade of 74. The next student had 12 absences and a grade of 58. The next student had 5 absences and a grade of 90. And then my final student had 8 absences and a grade of 78. So we can see our correlation coefficient is negative 0.944. The fact that this correlation coefficient is negative does match the fact that we said that the shape was a negative, the direction was negative in the first place. So that does line up to what we expected. And the fact that this is 0.944, so it's very, very close to -1, means these points are actually very, very close to a line. Let's look at one more example. This is one we looked at previously that looked at the number of cars in 10,000s that a rental car company had and their revenue in billions. So let's see about calculating the correlation coefficient. In my calculator, I'm going to hit the 3 dots. And this time I have the correlation coefficient in recently used. Open my parentheses for my first point. And the first one had 63 cars and 7 in revenue. The next point was 29 and 3.9. The next one was 20.8 and 2.1. The next one was 19.1 and 2.8. I then had 13.4 and 1.4, and then the final entry in this table was 8.5 and 1.5. So this time my correlation coefficient is roughly 0.982. The fact that this value is positive does match the fact that we said our direction of this graph was positive, and the fact that this is really close to 1 means that there is a really, really strong relationship here. It really does get really close to a line.